Hello, everyone. Thank you for coming today. We are the Gator Informatics from the University of Florida, and we are going to present a software-based solution on the current healthcare system of Cuba. My name is Jorge Figueres, and I am a first-year biomedical engineering student at the University of Florida.
And I'm Adrian Moya, and I'm a third-year computer science major at the University of Florida.
I'm Daniel Fuenoyor, and I'm a mechanical engineering major at the University of Florida.
And I'm Alvaro Mejed. I'm a first-year computer engineering student at the University of Florida. And so, in order to understand more about our project, first you have to come to understand the current state of Cuba's healthcare through the system of doctors and hospitals as well as the health disparities. Now, the system of doctors and hospitals in Cuba is not in the same format as that found in the United States. Every square block is assigned one doctor who runs a local clinica. This allows for a doctor-to-patient ratio of 1 to 170, which is half that of the United States and one of the world's best. These doctors treat their patients regularly in the clínicas and are able to treat them for their regular illnesses and ailments. They're also able to prescribe them medicine that can be purchased very inexpensively or for no cost at local state-owned pharmacies. However, hospitals are mainly used for major emergencies, such as the treatment of an extensive injury or the treatment of a disease such as cancer. One of the biggest emphasis that Cuba has on their health system is the emphasis of primary and preventative care. This means that as children are growing up, they receive all the proper vaccinations in order to ensure that future outbreaks will not occur. Also, women that are pregnant are brought monthly into the clinics to receive checkups for blood tests and other checkups to make sure that everything will be fine when their children are born. And this is a proven method considering that Cuba has one of the lowest infant mortality rates in the world. Now, the three health disparities shown are largely due to miscommunications between parties in the healthcare system. Medicine is lacking due largely to supply as well as regional shortages. So, for example, a local pharmacy in one area might have an excess supply of a given medicine, while another pharmacy in another area may be lacking in that medicine, so it could be better distributed. The medical supplies also fall into the same boat. So what happens often is that many people will go to the doctors and the same medical supplies will be used for months and years at a time due to the lack of supplies, and there is also improper sanitation and cleaning, so diseases can be born there also. And then another problem that they have is the lack of medical records. So basically, if a patient were to go see their regular doctor and they were referred to a specialist, that specialist would have a difficult time finding their actual records and being able to distribute it to the doctors, and so the need for a centralized record is needed.
So our solution to the problem, the current situation in Cuba, is to create an organized database software in which two tasks will be performed, one in which a centralized healthcare system will be kept, as into all the records of the healthcare patient, the records of all the patients will be kept. And another portion of our program consists of the analytics and predicting trends to certain diseases and also certain lacks of medical supplies throughout the island to better create a more efficient healthcare system. So our first part of our program is the record-keeping part of our program. It consists of a real-time system in which doctors will be able to input information about patients to one centralized database. Also, supplies in each hospitals will be inputted into one database along with the patient's medical history. From there, we will import that records to an analytical program in which graph trends can be created, and also we can make predictions to allocate supplies efficiently throughout the island and also to predict certain trends of diseases that happen throughout the island to create a more efficient healthcare system and to make a better profile of the island and to predict better analytics to the current healthcare. So we are going to give you a demo of the program that we made, and Adrian will go ahead.
Okay, so now I'm going to walk you through the prototype of the program that we made, and this is simply the main menu of it. You'll be seeing more of it in a second. So what is our program and what does it do? As we mentioned, our program is a database program that is going to take information from files that we have designed, and I'll be showing you that in a moment, and then it is going to parse that information into different objects and put them into a database. Now, this program is written in Java, which is very lightweight and portable. It's operating system independent. So that means the client side of this program that will be distributed to hospitals will be very easy to implement in a practical setting. Now, how it works, as I mentioned, is it takes the input from the files. We also have created an algorithm for testing purposes for the sake of this simulation that will create random data over the course of a year, and that's what I'm going to be using to show you some of the functions of the program. Finally, once the data is actually in the database, any end user on the client can search for a hospital and a doctor or a patient and get back any relevant information over the time encapsulated in the database about what they're searching for. And then perhaps most importantly, the program is going to take that data and all compile it into organized spreadsheets that chart the data over time, which can then be imported into the second part of our program, which will allow us to analyze the trends. Okay, so the first part of our program is the input files, and I'll be showing you here, these are the files we have designed. They're very simple, they're text files with the data that you need. We have made these, they're relatively short because we did them by hand, but you can see that there's the date that this is representing. In our test case, we did it per month, but in real time it can be per day, per week, any time interval that you need. And we made it so simple on purpose because in practical settings, it may not be feasible to get computers or network access to every hospital in Cuba. So this makes it easy for a form that we have designed to fill out by hand and then be mailed to a centralized location where this data can be input on whatever time period that you need. So now moving on to the program itself, if we take those input files and we go here to our program to the data entry portion, you can see that we point it to a directory where the input files are going, and you can see that second line is for the output directory, and I'll be showing you that in a little bit. But once we hit that OK button, it is going to take those two files that I have there, and it's going to parse them into the database as two different months. So once that's done, we can browse the database manually by hitting on that second button, and this is just going to show you all the information in the database in order. It's going to show you per month, each hospital, and the location of the hospital, all the doctors that work there, the patients that those doctors have seen on that month, what the patient's illnesses were, and as well as the supplies that are being kept track of. This is everything in the database, but if you want to get more specific, I'll show you that in a moment. The next thing we're going to do is generate the actual simulation that we used for this, which we did using a random data algorithm. And so if we go back to the data entry screen, and instead of pointing it to a directory, we just type in the word random, it's going to run that algorithm. And that is going to create data for a whole year on a monthly basis, and it's going to create hospitals with a certain amount of 10 supplies that we're keeping track of, as well as doctors that have random names along with a random amount of patients that they see every month, and what those patients have is also random. Once we do that, we're going to go and show you the hospital search function. The hospital search works by putting in the name of any hospital that you want to look for, and it's going to show you that the supplies that that hospital had on hand for every month that's in the database. So in our test case, the hospitals are simply named Hospital 1, Hospital 2, etc. So if we type in Hos 1 there, it's going to show us the first hospital, the doctors that work there, and per month, all the different quantities of supplies. In the same way, if we go to the doctor search function, we can type in the name of any doctor from the database. And again, they were randomly generated, so I went here and I copied one and I can paste it there into the field and then search for it. And it's going to show you the doctor, what hospital they work in, and then all the patients that that doctor has seen throughout the course of, in this case, a year. Finally, similarly, we can look at the patient search. And in this case, you can put in the name of any patient that you're looking for. And because there are so many patients in this database, and there's not that many names that it could possibly be, my name will probably be one of them. So if we type in my name there, and then search for it, we'll see all the times that I checked into a hospital in Cuba over the fictional next year. It'll show you every time what hospital I checked into and which doctor I saw and what my symptoms were. Finally, we can move over to the analytics portion of our program. And this portion, we're going to go first to that second directory that I mentioned at the beginning, where the output directory. And that is where two spreadsheets are going to be generated once we hit that Run Analytics button on the bottom of the program. The first spreadsheet is going to be for supply analysis over time, and the second spreadsheet is going to be for illness analysis over time. So you can see that they both are generated right there. And if we go to the next slide, we'll see first the supply analysis spreadsheet and the structure of that. And you can see here that the way it works is each hospital that's in the database is represented by a column, and each row, it represents a certain supply that we're keeping track of. And you can go, each different sheet of the spreadsheet is a different month over the time period. And in the same way, the illness analysis keeps track of all the patients that have checked into a certain hospital and what their symptoms were, so we can see the frequency that each illness that we are monitoring shows up in each geographic location, represented by a different hospital. These spreadsheets are essential for the next part of our program, which is handled in the MATLAB portion, and for that, I'm going to hand it over to Daniel Fuenmayor.
Thank you. So after Adrian's program has formatted all the data into spreadsheets, we then turn to the second part of our concept model, which involves data processing. And for this, we decided to use MATLAB. MATLAB was a natural choice because of the way in which it handles numbers. It stores them in arrays and provides a means to write various scripts, as you can see here, and functions that can let you manipulate that data in any way you want, really. It's important to note that when you analyze the data with MATLAB, you store the XLS files in a location where it can easily access the spreadsheets. So when we import the medical records, it's as simple as implementing a pre-written script that stores every month from each sheet into a matrix. And you can see here that in Adrian's program, the format of the data is preserved in MATLAB. All I have to do is call the name of the month, and it'll return the data to you. This script was written to analyze the trends of supply use in every single hospital over the course of 1 year. Each line refers to a different hospital. On the x-axis you have different months, and on the y-axis the quantity. This is helpful because should there be any instances, like say here in March, where one hospital has quite a bit of one supply, but other hospitals are lacking, you can compensate for that by reallocating the supplies. This script allows us to do a total inventory of all the supplies in every single hospital for any month we desire. Again, every single hospital is denoted by a different colored bar. And each number here corresponds to a different supply depending on how it was formatted in Adrian's program. And this is another script which is very useful for tracking the spread of disease across a full year in each hospital. In this case, it's strep throat. This can be very useful for modeling and making predictions after you've collected data for long enough, and would be very useful in allocating necessary supplies to treat such diseases. So in conclusion, it's our hope that this concept model helps explain how a real-world implementation of our solution could work and benefit the Cuban healthcare system. In total, we estimate the cost to be around $35 million, and that includes computer infrastructure, programming costs, development, training, and maintenance of the system. But it's important to note that we do think that the initial cost is outweighed by the efficiency that it could bring to the healthcare system. And there is a lot of potential in the future to not only do simple analysis for, say, supply, movement, and disease, but include it in a broader sense where you can improve on data analysis and make for a better healthcare system.